Good morning. John Gilkison here. It's Friday, March 6th, and I wanted to do an addendum to the parts 1 and parts 2 of the stealth trailer towing videos I shot uh, specifically for electric vehicles and internal combustion engines also, of course. But this one's case specific. We went over all the general principles uh, of aerodynamics as it applies to trailer towing, and it's just going to vary. That's the takeaway message from this. It depends on the vehicle and the trailer and the combination, and you're going to get all kinds of different results depending on gap closures, frontal area, uh, wake area, and so forth. So I wanted to get into a specific case to show you what we're talking about. And this is going to be the Tesla Model X towing a Bowlus travel trailer, and how we could, the Bowlus is one of the most aerodynamic trailers on the market, but how it could be even cleaned up further, and what this would result in, and how it would make towing viable for an electric vehicle with only a 3-gallon gas tank equivalent of energy on board. So here we are. I'm going to turn it over to the PowerPoint, and this is our title: Stealth Trailer Towing (parentheses 4 EVs), a specific case study for the Tesla Model X towing a Bowlus NASA Tamai. Tamai is the engineer that worked on this. So, and of course you know who NASA is. This is a Bowlus Road Chief, circa 1936. This trailer is still sold. It's a high dollar item like an Airstream is, and but it's one of the most aerodynamic trailers on the market. As you can see, it has a boat tail here. The wheels are underneath, built into the vehicle. They don't stick out. And the front end is just rounded off. It's got rounded edges. And it's not really designed for gap closures or fairings in mind, because it's kind of a V-nose trailer, and that can cause a few problems. But anyway, it's still one of the best. So here we are. This is the outline of the steps, the iterations. So first you start out with your Tesla Model X, which is capable of 216 watt-hours per mile at 55 miles per hour. That's the key here. And then you're towing the trailer. And you can see immediately you go up to 417 watt-hours per mile at 55 miles per hour. That's a 49% penalty on energy consumption. And then as you put in the air shield here, and then the gap closure, and then the skirting around, you finally get down to a 26% penalty. So you've cut the drag in half simply by these steps. So that's the overview. Now the Tesla Model X Solo at 151 miles per gallon at 55 miles per hour. This is really good for an SUV, not to mention the Tesla Model X many other attributes. The Tesla is rated to tow 5,000 pounds. In towing box trailers, and this is why I put this in red, without air screens, the Model X is a disadvantage over pickup trucks, which have a larger wake area for, of course, the trailer to hide in. So this is your baseline here, 216 watt-hours per mile. Here's a Tesla Model X statistics going solo. Now, the columns here didn't get marked, but we're 55, 60, 65, 70, 75, 80, 85 miles per hour. And then you have the watt hours per mile. So at normal highway speeds, let's say of 75 miles per hour, you're at 309 watt hours per mile. That's on the interstates. But at 65 miles per hour, you're only at about 260. So, and there's your road horsepower. So traveling at 55 miles per hour, you're only using 16 road horsepower. We're in large lawnmower territory here when you're talking about that. The vehicle weighs 5,400 pounds. Has a drag coefficient of 0.24. And there's your frontal area, almost 31 square feet, and so forth. Now here's your aerodynamic horsepower, and here's your rolling resistance horsepower. And you're going to note something right away, that the rolling resistance horsepower goes up in a linear fashion. Whereas by the time you go from 55 to 85 miles per hour, the aerodynamic horsepower goes from 8 to 29. That's almost four-fold increase. But the rolling resistance only goes from 8.5 horsepower up to 12, which is just a 50% increase. So there's your range. At 55 miles per hour, you could go over 400 miles in a Tesla Model X. But at normal highway speeds, 65 miles per hour, you're at 355 miles of range. 70, and that's the speed I like to drive on the interstates, 325 miles of range. And your MPG can go from almost 140 miles per gallon equivalent to at 70 miles per hour, it goes down to 106 miles per gallon. You're still above 100 miles per gallon. So at 60 miles per hour, you have a 9% penalty over 55, and then a 17% penalty at 65 miles per hour, a 23% penalty at 70, a 31% penalty at 75, and a 36% penalty at 80. Let's see here, 60, 65, 70, 75, 80, yes. Okay, this is an important concept right here. Here's just towing the Bowlus just straight up, 417 watt hours per mile. And then this is the Boreas, which is a off-road camping trailer. It's smaller and lighter than the Bowlus, but it's got this large gap here, and then it's got these excrescences strapped to the roof, and other things going on, the wheels sticking out, so forth. And although this is much smaller, lighter trailer, it takes 451 watt hours per mile to tow versus the aerodynamic trailer. So this shows you what aerodynamics can do. Here's a data sheet for the high drag Bowlus. If we are at 70 miles per hour, you're at 640 watt hours per mile. You've dropped the range to 140 miles, 44 miles. From over 300, you've cut it more than in half. Your MPGE is dropped to 47 miles per gallon equivalent. None of this is good, and it's just not necessary. With better design, you wouldn't have to pay these giant penalties. So here's your iterations for you adding an air screen, which is a NASA term, and that's what they use on semi-trucks. And then you still have this gap here, which is too large. So here you have a gap closure right here. So you went from 417 watt hours down to 357 watt-hours per mile. But there's one iteration left, and that's wheel skirting, where you're trying to keep air out underneath the trailer and cover the wheels. So then you've dropped to 291.5 watt-hours per mile. So this is a 30% reduction in energy by taking these steps. So this is a table for this. And I think the important takeaway here is at 65 miles per hour, your range has dropped to 272 miles from 316. So the extra 10 miles per hour. But this is the speed that I normally tow my fifth wheel. Now bear in mind, my fifth wheel, right here is where I'm talking about. My fifth wheel is 9,000 pounds, has 100 square feet of frontal area. And that is the most distance I have ever made with a 36-gallon gas tank in my pickup truck, is I went 270 miles between fill-ups. And I was nearly out of fuel. So I was having range anxiety when I stopped to fuel up. And this Tesla Model X can tow this trailer, which adds 3,000 pounds to the Tesla Model X. It's, instead of 5,400 pounds, it's going to weigh 8,400 pounds. And it can make 270 miles with these aerodynamic improvements. So there you are, and you're at 338 watt-hours per mile. Your MPG has only dropped to just below 90 miles per gallon. This is an incredible feat. You really have to take your hat off to the science here. It's I just don't think people get it. I get 9.5 miles per gallon towing my fifth wheel. And I can only go 270 miles, and this thing's getting almost 90 miles per gallon and can go 270 miles at 65 miles per hour. I mean, to complain about this, you'd just be the kind of person who would complain about being hung with a new rope. It's just ridiculous. But the important takeaway here is to keep your speeds below 65 miles per hour when you're towing a trailer. And you'll keep your range and energy use within reason if you do this. There's just no reason to be towing trailers at 75 or even 70 miles per hour. And this is my point again about rolling resistance. I'm going to try to button this up now. Again, it's just a linear function here. It only goes up by about 50% between 55 and 75 miles per hour. Aero horsepower, road load horsepower, watt-hours per mile. There's your frontal area right there, 49 square feet. So it's about half of what my fifth wheel is. There's your watt-hours per mile. Road load, that's what the engine senses. And notice how it goes from 21 horsepower up to 52. It more than doubles between 55 miles per hour and 85, as you'd suspect. And then the horsepower for the aero is cut out separately here. Other data, range drops from 316 miles at 55 miles per hour to 234 miles at 75 miles per hour. Range is still reasonable at 65 miles per hour at 272 miles. So there you have it. I'm going to wrap this up here. And this trailer is so pretty, I'm going to show it to you again. The Bowlus Road Chief, 1936. Just look it up on the internet. I think you'll be pleasantly surprised. It's a really nice trailer. We'll see you on down the road, everybody. Take care. Bye-bye.